Okay, in this video we will be learning testing the singularity of the given function. Okay, here the question is test the singularity of sin z divided by z power 4. Sin z by z power 4. We know sin z is given by z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial plus etc. Okay, this is sin z and all these these variables are z. Okay, z cube, z power 5, z power 7 plus etc. Now f of z is equal to, we assume this to be f of z. Okay, this is f of z. F of z is 1 by z power 4 into sin z. 1 by z power 4. What is sin z? Z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial plus etc. Now we can take this inside. Z by z power 4. What is z by z power 4? Z and z power 4 can be eliminated. So here eliminating, so let me write one more step here, which is equal to z by z raised to 4. Okay, z divided by z power 4 minus again z cube by z power 4 3 factorial, that is z cube by 3 factorial 1 by z power 4. Then plus here again 1 by z power 4 into z raised to 5 by 5 factorial minus, like it goes on like this, 1 by z power 4 into z power 7 by 7 factorial plus etc. And here you can cancel the terms z and this will become cube, and here this cube term and here 4, right? So you may have only z. Here z power 4, z power 5, you will have only z in the numerator. Here z power 4, this becomes z cube. Then you get 1 by z cube, 1 by z cube, here it is not there, 1 by z cube minus 1 by z3 factorial, z into 3 factorial, okay, 1 by z into 3 factorial plus then z by 5 factorial minus z cube by, okay, this is z cube by 7 factorial plus etc. So elimination you can do, okay, eliminating you get this. Now what is the principal part in this final equation? In this final equation, principal part is, okay, PART, principal part is 1 by z cube first term, second term minus 1 by z into 3 factorial. So all the other terms you see z is in the numerator. Principal part means in the principal part z will be in the denominator. Okay, that means negative powers of z. Z will be in the denominator. So we have 1 by z cube minus 1 by z into 3 factorial. So principal part has finite number of terms. Okay, principal part has finite number of terms. Finite means how many terms? 2 terms. So when principal part has finite number of terms, we say the singularity is a pole here. So how will you find the singularity? What is the function? So here z equal to, therefore z equal to 0 is a pole because principal part has finite number of terms. Okay, how will you find the singular point? By equating the denominator to 0. Here we have z power 4, right? Z power 4. So z power 4 denominator to 0, we get z equal to 0. Z equal to 0 is the singular point. Means at z equal to 0, function is not analytic. Okay, at z equal to 0, f of z is not analytic. That means it is a singular point. It is a z equal to 0 is a singular point. But test the singularity means we have to test whether it is a pole or essential singularity or whatever it is. Okay. So here in this case, z equal to 0, this it has finite number of terms. Therefore, z equal to 0 is a pole. Here z equal to 0 is a pole because principal part has finite number of terms. Next question, test the nature of type of singularity. F of z equal to e power minus z square by z square. Okay, the question is e raised to minus z square. Question is e raised to minus z square by z square. We know e power minus z is 1 minus z by 1 factorial plus z square by 2 factorial minus z cube by 3 factorial plus etc. So using this we are going to continue. E power minus z is given by this. So what will be e power minus z square? E power minus z square, replace z by z square, right? Here you have z, here you have z square. So in this place you have to replace by z square. So our answer will be 1 minus z square by 1 factorial plus z square the whole square is z square, right? So we have to write z square, then again one more square by 2 factorial plus minus z square the whole cube by 3 factorial plus etc. Okay, so we have to continue with this. So taking the square we get what we get? You get z square by 1 factorial, here z power 4 by 2 factorial minus z power 2 3s are 6, z power 6 by 3 factorial, that is z power 6 by 6. So now this particular function, okay, this e power minus z square can be replaced with this equation. Okay, now our function is e power minus z square by z square is our function. So e power minus z square by z square means in this function we have to divide by z square. So you have to divide each and every term by z square, divided by z square, or you can write like, you can write the z square here itself. Okay, divided by z square because you have a z square in the denominator. So you get 1 by z square minus here. What about the second term? This z square and z square will be, this is positive. Okay, z square and z square eliminated, 1 by 1 factorial. Here this is plus z power 4 by z square. So z square and z square. So again z square by 2 factorial. Here 2 3s are 6. 2 3s are 6. This is z power 6, right? So this will become z power 4. Z power 4 by 3 factorial. This is z power 4. Z power 4 by 3 factorial plus etc. So now what about the principal part? How many principal part terms are here? So when you say as principal part, it means the term, z term which is in denominator. You see, this is the only term, 1 by z square. Principal part has finite terms. That is, how many terms? Denominator with z in the denominator, only one term. That is single term. So principal part has finite term. Therefore, when principal part has, this is principal part because here you see, here z comes in the numerator, but here z comes in the denominator. So whenever z comes in the denominator, we say that is the principal part. How many principal part terms? Only one term, that is 1 by z square term. So we say z equal to 0 is a pole here. Okay, so we say z equal to 0 is a pole because principal part has finite. This is the principal part, it has only finite terms. Continue with the residues. Okay, residues. The residue, what is a UES? Okay, residues. If z is equal to a is an isolated singularity of f of z, then f of z can be expanded in a Lorentz series about z is equal to a in the form f of z equal to summation n equal to 0 to infinity a n z minus a whole raised to n plus summation n equal to 0 to infinity b n z minus a whole raised to minus n. Whole power minus n. Okay, negative power. This is positive power of n, whole power n, whole power minus n. The coefficient of the coefficient b1 of 1 by z minus a is called residue. So what is a residue? Is called a residue. Coefficient of b1. So when you expand this, you will come across term like b0 z minus a whole power 0 plus b1 z minus a whole power minus 1 plus etc. Right? When n takes 0, you get the first term. When n takes 1, you get this term. Likewise. So here coefficient of b1 is called residue. That is, what is coefficient of b1? Coefficient of b1 is z minus a the whole inverse, that is 1 by z minus a. So this is called as residue. Okay, this is called as residue. Okay, this 1 minus z minus a is residue, and a residue of f of z at z equal to a is denoted by residue f of z at the point a. So residue is denoted by residue f of z. Residue at the point a is denoted by residue f of z at the point a. We have certain method to find the residues. Okay, how to find residue? So to find the residue, what we can do is, we have the equation. If z is equal to a pole of order m, then residue f of z at the point a is 1 by m minus 1 factorial. Okay, 1 by m minus 1 factorial, limit z tends to a, d power m minus 1 by d z power m minus 1, that is m minus 1 derivative. So we will write the derivative, right? So that is m minus 1 derivative of, so derivative of what is that? Z minus a whole power m into f of z. So this is m, the derivative, d m minus 1 dz m minus 1, then derivative of z minus a whole power m into f of z. Okay, f of z, that's the formula here. Then second case, if z equal to a is a simple pole, that is z equal to a is of order 1. Okay, so order is 1, then residue is given by limit z tends to a, z minus a into f of z. Limit z tends to a, z minus a, small a. Okay, z minus a into capital F of z, or this function f of z. So in the next video we will be doing problems that is using this equation, how to find residues and